to enhance safety during the replacement of site lighting fixtures, particularly when existing systems lack equipment grounding conductors, or EGs. A systematic approach is essential. Firstly, installing new EGC involves excavating a trench alongside existing conduits. Install new THWN or THWNC copper grounding conductors, with the wire size determined by the lighting load. Connect the EGC to the grounding terminal of the junction boxes and the grounding provisions of the replacement fixtures. Secure the EGC to the poles using appropriate clamps or straps. Secondly, consider the installation of ground rods if the soil has poor conductivity. Install ground rods alongside the trench and connect them to the EGC system. This will provide a low-resistance grounding path. Thirdly, if the existing junction boxes have no EGC provisions, replace them with new boxes that have a grounding terminal or screw. Fourthly, if the lighting poles are metallic, they must be bonded to the EGC system using green insulated bonding bushings or other approved methods. Fifthly, ensure proper connection by using appropriate connectors and methods to guarantee secure and reliable connections between all components of the grounding system. Tighten all connections to the specified torque. For additional considerations, 1. Check with local authorities to determine if a permit is required for this work. 2. While working with electrical components, always follow proper safety protocols, wear protective gear, and ensure proper grounding during all stages of the installation. 3. Consider protecting the EGC and other grounding components from corrosion by using appropriate compounds or coatings. Mark the locations of the EGC and other grounding components clearly for future reference and inspections. The equipment grounding conductor, or EG, plays a critical role in electrical safety. It provides a low impedance path for fault current to return to the source, facilitating the quick operation of overcurrent protective devices like circuit breakers or fuses. This rapid response minimizes the duration of a fault, reducing the risk of electrical shock, fire, and equipment damage. The size of the EGC is determined by the size of the ungrounded conductors feeding the lighting fixtures. National Electrical Code or NEC Table 250.122 provides guidance on the minimum size of copper, aluminum, or copper-clad aluminum EGC based on the rating or setting of the overcurrent protective device protecting the circuit. For example, if the overcurrent protection is rated at 20 amps, a number 12 American wire gauge or AWG copper EGC is typically sufficient. If the overcurrent protection is 30 amps, a number 10 AWG copper EGC is required. For a 60 amp overcurrent device, a number 8 AWG copper EGC is needed, and so on. When installing ground rods, it's important to consider soil conditions. Soil resistivity affects the effectiveness of ground rods. Sandy or rocky soil typically has higher resistivity than clay or loam soil. To ensure a low resistance grounding path, multiple ground rods may be required. The NEC section 250.56 requires that if a single ground rod has a resistance to ground greater than 25 ohms, an additional ground rod must be installed. The ground rods should be spaced at least 6 feet apart to avoid overlapping their effective grounding zones. Common ground rod materials include copper, copper-clad steel, and galvanized steel. Copper and copper-clad steel offer excellent corrosion resistance, while galvanized steel is a more economical option. The minimum size of a ground rod is typically 8 feet in length and 5/8 inch in diameter. When replacing junction boxes, select boxes that are suitable for the environment and application. Weatherproof boxes are essential for outdoor lighting installations to protect against moisture and corrosion. The junction boxes should be made of durable materials such as aluminum, stainless steel, or non-metallic materials like fiberglass reinforced polyester. Ensure that the junction boxes have adequate space for making connections and that they are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or UL. Bonding the lighting poles to the EGC system is crucial for preventing voltage gradients and ensuring that the poles are at the same potential as the surrounding earth. This minimizes the risk of electric shock if a fault occurs. Green insulated bonding bushings are commonly used to connect the EGC to the metal pole. These bushings provide a secure and reliable connection while also insulating the EGC from the pole to prevent corrosion. Other approved methods for bonding include using grounding lugs and bonding jumpers. When making connections, use appropriate connectors that are listed for the specific application. Compression connectors, such as those conforming to Underwriters Laboratories or UL 486-486B, are commonly used for making reliable connections between conductors. These connectors provide a gas-tight connection that resists corrosion and ensures a low-resistance path for current flow. Follow the manufacturer's instructions for installing compression connectors, including using the correct crimping tool and die. Torque all connections to the specified torque value using a calibrated torque wrench. Under-torqued connections can loosen over time, leading to increased resistance and potential overheating. Over-torqued connections can damage the connector or conductor, compromising the integrity of the connection. Consult the manufacturer's instructions or applicable standards such as the NEC for recommended torque values. Obtain any necessary permits before starting work. Local authorities, such as the city or county building department, typically require permits for electrical work to ensure compliance with applicable codes and regulations. The permit application process may involve submitting plans and specifications for the proposed work, paying a fee, and scheduling inspections. Comply with all applicable safety protocols while working with electrical components. De-energize the circuit before starting any work. Use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated footwear. Use insulated tools to prevent accidental contact with energized conductors. Follow lockout/tagout procedures to prevent the circuit from being accidentally re-energized while work is in progress. Protect the EGC and other grounding components from corrosion. Corrosion can degrade the performance of grounding systems, leading to increased resistance and potential failure. Use corrosion-resistant materials, such as copper or stainless steel, for grounding components. Apply corrosion-inhibiting compounds or coatings to grounding connections to protect them from moisture and chemicals. Consider using cathodic protection systems, such as sacrificial anodes, to protect underground grounding components from corrosion. Clearly mark the locations of the EGC and other grounding components for future reference and inspections. This will facilitate troubleshooting and maintenance. Use permanent markers or labels to identify the location of grounding components. Create a site plan showing the location of all grounding components. Keep accurate records of all grounding system installations and modifications. Regular inspections of the grounding system are essential to ensure its continued effectiveness. Inspections should be conducted at least annually or more frequently in harsh environments. During inspections, check for signs of corrosion, damage, or loose connections. Test the resistance of the grounding system to ensure that it meets applicable code requirements. Keep records of all inspections and maintenance activities. In summary, upgrading site lighting grounding involves several key steps. These include installing new EGC ground rods and junction boxes, bonding the lighting poles to the EGC system, ensuring proper connections, obtaining necessary permits, complying with safety protocols, protecting grounding components from corrosion, and clearly marking the locations of grounding components. By following these steps, you can ensure that your site lighting installation is safe and compliant with applicable codes and regulations. The selection of the appropriate wire size for the equipment grounding conductor, or EG, is crucial for ensuring electrical safety. The NEC provides guidance on determining the minimum size of the EGC based on the rating of the overcurrent protective device protecting the circuit. NEC Table 250.122 specifies the minimum size of copper, aluminum, or copper-clad aluminum EGC for various overcurrent device ratings. For example, if the overcurrent device is rated at 20 amps, a number 12 AWG copper EGC is typically sufficient. If the overcurrent device is rated at 30 amps, a number 10 AWG copper EGC is required. For a 60 amp overcurrent device, a number 8 AWG copper EGC is needed. It's important to note that these are minimum sizes, and larger EGC may be required in certain situations, such as when the circuit conductors are upsized for voltage drop. In addition to the NEC requirements, local codes and regulations may also specify minimum EGC sizes. Always consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. When installing ground rods, the depth and spacing of the rods are important factors to consider. The NEC requires that ground rods be driven at least 8 feet into the ground. The top of the ground rod should be flush with or below ground level unless protected against physical damage. If multiple ground rods are used, they should be spaced at least 6 feet apart to avoid overlapping their effective grounding zones. In areas with rocky soil, it may be difficult to drive ground rods to the required depth. In these cases, the ground rods can be buried horizontally in a trench at least 30 inches deep. The trench should be backfilled with soil that is free of rocks and debris. The selection of appropriate junction boxes is critical for ensuring the safety and reliability of electrical connections. Junction boxes should be listed and labeled by a recognized testing laboratory, such as UL. The junction boxes should be made of durable materials that are suitable for the environment in which they will be installed. For outdoor applications, weatherproof junction boxes are essential to protect against moisture and corrosion. The junction boxes should have adequate space for making connections and should be equipped with grounding terminals or screws for connecting the EGC. The installation of bonding jumpers is essential for ensuring electrical continuity between metal parts of the electrical system. Bonding jumpers are used to connect metal enclosures, raceways, and other metal parts to the EGC. The size of the bonding jumpers should be determined based on the size of the circuit conductors. The NEC provides guidance on the minimum size of bonding jumpers in Table 250.102. Bonding jumpers should be installed in a manner that provides a lower impedance path for fault current to flow back to the source. The use of appropriate connectors is critical for ensuring reliable electrical connections. Connectors should be listed and labeled by a recognized testing laboratory such as UL. The connectors should be compatible with the type of conductor being used, such as copper or aluminum. Compression connectors are commonly used for making reliable connections between conductors. These connectors provide a gas-tight connection that resists corrosion and ensures a low resistance path for current flow. Follow the manufacturer's instructions for installing compression connectors, including using the correct crimping tool and die. The proper torquing of connections is essential for ensuring reliable electrical connections. Under-torqued connections can loosen over time, leading to increased resistance and potential overheating. Over-torqued connections can damage the connector or conductor, compromising the integrity of the connection. Use a calibrated torque wrench to torque connections to the specified torque value. Consult the manufacturer's instructions or applicable standards, such as the NEC, for recommended torque values. Regular inspections of the grounding system are essential to ensure its continued effectiveness. Inspections should be conducted at least annually, or more frequently in harsh environments. During inspections, check for signs of corrosion, damage, or loose connections. Test the resistance of the grounding system to ensure that it meets applicable code requirements. Keep records of all inspections and maintenance activities. By following these guidelines, you can ensure that your site lighting grounding system is safe, reliable, and compliant with applicable codes and regulations. The importance of a properly installed and maintained equipment grounding system cannot be overstated. It is a critical component of electrical safety and plays a vital role in protecting people and property from electrical hazards. Investing in a robust grounding system and performing regular inspections and maintenance is a wise investment that can pay dividends in terms of safety, reliability, and peace of mind.